Welcome back. Now that we have our character and our enemies, we need to be able to move them around. This means we need to be able to handle input. Specifically for aura, we're going to deal with the aura character first, and in order to move aura around in the level, we need to handle input. And the way to do that is to set up enhanced input for our character. So we're going to do that. I have a lot of windows open here, so what I'm going to do is hover over each of the tabs and simply click the middle mouse button to close those. So closing all of these down. Now we've got that under control, and we can set up enhanced input. Now for movement, we're going to need an input action. So in my content drawer, in blueprints, I'm going to create a new folder called input. And here in inputs, I'm going to make yet another folder called input actions. And all of our input actions will go into this folder for this project. Now, an input action is required for enhanced input in order to take input from some sort of device, such as the keyboard. So for movement, we're going to make a new input action by right-clicking, going to input, and selecting input action. And the convention is to put IA for input action, and we'll call this one move. Now, I'm going to open up IA move. And the only thing I roll this one action by right-clicking, going to input, and selecting input action. And the convention is to put IA for input action, and we'll call this one move. Now I'm going to open up IA move. And the only thing I really want to change here is the value type, because for movement, I want to be able to handle two-dimensional movement. Left and right is the first dimension, forward and backward is the second dimension. So I'm going to change this value type to axis 2D, vector 2D. That's going to allow me to take input in the form of a two-dimensional vector with two axes, x and y. I'd like to consider x to be left and right, and y to be forward and backward. Now, let's not get confused here. In three-dimensional space, we typically consider an actor's forward vector to be the x-axis for that actor. But for movement, we're talking about a 2D axis space. Look at the W, A, S, D keys on your keyboard. W and S will be forward and backward. We're going to consider that to be the y-axis in this 2D space. A and D will be left and right. We'll consider that the x-axis in this 2D space. So now that we have an input action, the way that we link this to our character is going to be through an input mapping context. And that's where we can associate keyboard keys with our input action IA move. So back in our input folder, I'm going to go back up one level. We'll put our input mapping context right here. So I'm going to right click, go to input, and select input mapping context. And I'll call this IMC for input mapping context. Aura context. And I'll go ahead and open this up. And here we have our mappings, an empty array currently, but if I click plus, I can add one and open the dropdown and select an input action. Opening this up, I see that the only one available is the one I just made, IA move. I'll select that. Now that we have IA move in this input mapping context, we need to associate it with various forms of input. Now, for the time being, I'm just going to set up WASD movement at this stage in the course. So what I'll do is I'll click on the keyboard icon here and then press D. We'll start with the D key. The D key is perhaps the most simple. When we press D, we want to move to the right. Now, I'd like to add additional keys to this, so I'm going to press the plus icon next to IA move and get another mapping. I'm going to click the keyboard icon and press A. Now, pressing D moves us to the right, pressing A is going to move us to the left, which means further down the line in our code, when we set up the ability to respond to user input, we're going to access data that we retrieve as a result of these mappings, and pressing D and A will both result in us retrieving data, but when I press A, I'd like that data to be negative. I want to receive a positive one when I'm pressing D and negative one when I'm pressing A. And in order to do that, I have to modify that input using a modifier. So under A, I'm going to click plus for the modifiers, and for this modifier, I'll open the dropdown and choose negate. If I open that index, I see that it's going to negate all three axes, but D and A are just going to be on the x-axis. And remember, IA move is a two-dimensional input action with two axes. So the z-axis here has no meaning for us in any of our modifiers for IA move. But D and A, those are going into the x-axis. Remember, I said A and D is left and right. We're considering that the x-axis in this two-dimensional space for IA move. So we're going to negate that x-axis. We don't need y or z checked. We just want to negate the x-axis here. So that takes care of D and A, but we want to move forward and backward as well. So I'm going to click plus to add another key, click the keyboard icon and press W, and this will be for moving forward. Now, we don't want to negate it. When I press W, I want to receive a positive 1 value. However, I don't want to receive it on the x-axis. In the two-dimensional space for IA move, I want to receive a positive 1 in the y-axis. For that reason, I have to add a modifier that will force the W key to provide input data in the y-axis for IA move. So I'm going to add a new modifier. From the dropdown, I'm going to choose swizzle input axis values. That's how we swizzle or change the axis that this key will feed data into. And if I open the dropdown, we see the order. The order is set to Y, X, Z. But by default, input goes into the x-axis first, but if we swizzle it, it now goes into the y-axis first. So now W will feed data into the y-axis. So that takes care of moving forward, but I want to move backward as well. So I'm going to add yet another binding. And for this one, I'll click the keyboard and press S. This will be for moving backward. Now this one is going to need a couple of modifiers, right? For one, we know we'll need to swizzle it, like we did with W, into the Y-axis, but we also want to negate this input value, so we get a negative value, and we'll know that we can move backward in that case. So we'll add two modifiers. The first one is going to be the negate, and then we'll add a second modifier that will be swizzle input axis values, and as we can see, it's going to go into the Y-axis, as that's the first letter in the order. So now that we have an input mapping context, and we have WASD keys set to feed the correct data into the 2D axis values for IA move, we need to actually use that data to move the character. Now, we could do this in the character class if we like, but in this project, we're going to handle controlling the character in the player controller class. We don't want to crowd up the character class with too many responsibilities, and the player controller class is a perfectly valid class to handle movement for the character that controller is possessing. So our next step is to create an Aura player controller class. And that's going to be your quest. Create a new class based on player controller and call it Aura player controller if you're following along with the same naming conventions. Now, make sure that this goes into its own player folder, just like our characters went into our own character folder. Pause the video and conquer this quest now. Okay, so I need a new C++ class. I'm going to go into C++ classes and Aura and public. And we'll right-click right here to make a new C++ class, and this will be a player controller. So here's the player controller class, clicking next. And instead of just going straight into the public folder, I want to be organized. So I'm going to type /player, and we'll put the player controller in the player folder. And I'm going to call this class Aura player controller. So let's go ahead and create that class. And I'm going to click no so I can compile this myself and create that. And I'm going to call this class Aura player controller. So let's go ahead and create that class. And I'm going to click no so I can compile this myself. And I'll go ahead and close out of the editor. And there's my player folder here in Writer. And we now have Aura player controller.h and CPP. So we're ready to associate our enhanced input action and input mapping context with our character. We're going to do so in Aura player controller. And we're going to do that in the next video. Welcome back. We're now ready to associate the enhanced input assets that we created in the editor with our player controller. So I'm going to go into Aura player controller here and open that up. I don't think I need my character classes open at the moment, so I'm going to right click on Aura player controller and close other tabs. Visual Studio has a similar option. Now I'll go ahead and open Aura player controller.cpp and .h. I'll have them both open here. And here in the header file, we're going to need a couple of functions. Now we created an input mapping context, and the place to add that to our player controller is in begin play. Begin play is a protected function. I'm also going to want a constructor, and that will go in the public section. So I'm going to want a couple of sections here. I'm going to make a public section and a protected section. And in protected, I'm going to override begin play. So it's virtual, it's void. We're going to declare begin play, and that's an override. And in the public section, we'll make a Aura player controller constructor. And we can define these functions. I'm going to let Writer create the definition for me by clicking on the hammer and selecting generate definition. And for now, the only thing I'd like to do in Aura player controller in the constructor is make sure that this player controller replicates. So the player controller has a b replicates boolean that we can set to true. And we'll talk more about what replication implies throughout the course. But replication, essentially in multiplayer, is when an entity changes on the server. That change that took place on the server will replicate or be sent down to all clients connected to the server. So we have a concept of changes being made on multiple machines. One of those machines is the server, and all other machines are clients. So replication is responding to data updating on the server and sending that down to clients. So we're just going to make sure that our player controller is designated to participate in that. To be a replicated entity. So there's our constructor, and now let's make a definition for begin play. Thanks to Writer, I have super begin play automatically. If you're using Visual Studio or another IDE, don't forget your call to super, very important. So here is where we're going to add the input mapping context. And our player controller is going to need a variable to store that input mapping context. So we'll go ahead and make that member variable here in Aura player controller, and that can be a private variable. So we'll make a private section down at the bottom. I just happen to like my private section below the protected, which is below the public, and you may wish to organize your structure differently, and that's fine. Now I need a pointer for a U input mapping context. That's the C++ type for input mapping context. So I'm going to make a T-object pointer to U input mapping context, and I'm going to call this Aura context. And of course, this will be a U property, and I'd like to be able to set this in the player controller blueprint. So I'll make it edit anywhere, and I'll put it in the category of input. Now, if I hit Control-Shift-B to the protected, which is below the public, and you may wish to organize your structure differently, and that's fine. Now, I need a pointer for a U input mapping context. That's the C++ type for an input mapping context. So I'm going to make a T-object pointer. Of course, this will be a U property, and I'd like to be able to set that, put it in the category B to compile identifier. After all, we can just, so it's where we need to use it. That means that enhanced right here in public dependency module names, just to make sure that we can access that module. And I'll save and close out of the build file. So now that I have an Aura context and we're planning on setting that in the blueprint, let's go into begin play and we can add this mapping context. Now, Aura context may or may not be set. Remember, we need to set that in the blueprint, and if we haven't, then this won't be a valid pointer. And if it's not valid, well, then we'll have all kinds of problems, such as input not working. And that's something that's serious enough, I think, to halt execution altogether for, so that we can set that input mapping context on the player controller. We shouldn't be allowed to continue trying to play the game if input isn't going to work. So for that reason, I'm going to use an assert. We can use check here, and we'll check the Aura context pointer. So check is going to halt execution if this condition fails, and Aura context, being a pointer, will be evaluated as false if it hasn't been set yet. So this is a good way for us to assert that our Aura context is set. And if we try to run the game without setting it, we'll get a crash. Now, the way to add an input mapping context is we access the enhanced input local player subsystem. That's a subsystem whose type is U enhanced input local player subsystem. We're going to make a pointer to this. We'll call this subsystem. And the way that we can get it is through a static function that belongs to the uLocalPlayer class. So to access a static function, we use the class name uLocalPlayer, :, and we can use the function get subsystem. This is a template requiring a type. We're going to use this type, uEnhanced input local player subsystem. And the function will require an argument of type uLocalPlayer, which we can always get with the function get local player. So now we have this local pointer subsystem of type uEnhanced input local player subsystem. Subsystems are singletons. There exists only one for the duration of the program. And the enhanced input local player subsystem is what we can use to add mapping contexts, such as our Aura context. Now, we can place this all in an if check. That way, if this subsystem pointer is null, we won't try to access it. Or we can do like we did with Aura context and simply do a check with check subsystem. The difference between using an if statement to check the pointer and an assertion is that, of course, if subsystem is null, we'll get a crash here. Now, after checking subsystem, we can take subsystem, and we can use the function add mapping context, which requires an input mapping context. We have our Aura context and a priority, as you can have multiple input mapping contexts at the same time, and if they're competing with each other for the same input, well, then you can use priority to determine which input wins. We just have a single input mapping context, and we're going to keep that priority value at 0. So now our input mapping context is set here. Now, while we're in begin play, we can set a number of settings that our player controller has control over, such as things like showing the mouse cursor. As the player controller has a bShowMouseCursor boolean, we can set that to true. In this top down, we're going to want to see our cursor. We can even set the default mouse cursor, and this is an enum of type E mouse cursor. So we have a number of different cursors. I'm going to use the default mouse cursor. And we can also set the input mode. Now, the struct f input mode game and UI is an input mode struct. And if we use this input mode, then we'll be able to use input from our keyboard and mouse, and we'll also be able to use input to affect UI, such as widgets. And we'll have lots of that in this project. So I'm going to create one of these called input mode data and take input mode data and configure it a little bit. I'm going to use set lock mouse to viewport behavior. This takes an E mouse lock mode. I'm going to choose do not lock, and that way we will not lock our mouse to the viewport. I'm also going to take input mode data and use set hide cursor during capture to false. So as soon as our cursor is captured into the viewport, we will not hide the cursor. And in order to use this input mode data, we use the player controller's function set input mode, passing in the input mode data. So now our cursor settings are configured, and now we have our subsystem set up. up. And we're using some class. And the way that we can get it, if it's not valid, well, then we'll have all kinds of problems together for if input isn't going to condition. And so this is the game. The enhanced, all this function will read system context. Check. System is name inputs. Well, then you can use text. So I'm going to make a t-object pointer. We can only success. It means we need to go over to our aura.build.cs and now in aura.build.cs, I have an aura context, and we're planning on just to make sure that we can access that module. And I'll say CS and make sure to add input module that contains these header files for enhanced inputs and make sure to add enhanced input to our module names. So I'm going to go ahead and do that now. Right here in public dependency module names in aura.build.cs, I'm going to add enhanced. And I'll say, and we're planning on mapping content, set that in the, it's not, and so that we can do, I'm going to the aura context, this can evaluate it, the enhanced input is through a static function that belongs to the class get subsystem. This is a template requiring a type. We're going to use this type you enhance input local player subsystem, and the function will require an argument of type u local player, which we can always get with the function get local player. So now we have this local pointer subsystem of type u enhanced input local player subsystem. Subsystems are singletons. There exists only one for the duration of the program. And the enhanced input local player subsystem is what we can use to add mapping contexts, such as if this subsystem pointer is null, we won't try to add and an assertion is that, of course, if subsystem is null, we'll get a crash here. Add mapping context, which requires an input mapping context. We have have our aura context and a priority, as you can have multiple input mapping contexts at the same time, and if they're competing with each other for the same inputs, well, then you can use priority to determine which input wins. We just have a single input mapping context, and we're going to keep that priority. So we have a number of different